Okay, hello everyone. Today we'll be doing paper 1 calculus section. Now in calculus questions you see there's always one question with the first principles that you have to apply the rule which is given in the formula sheet. I just attached the memorandum down here so we can go faster and more questions, more and different type of questions. So in regards to applying first principles, it's important to find f of x plus h correctly. That's the thing, because that's part of the formula f of x plus h. So from that we subtract the original function. So it is negative 2x squared will be subtracted, and there may be a few terms, so that's why it is better to write in brackets, so that minus in front affects the sign of the terms inside. Okay, so as you see we are subtracting, and that minus in front may affect the things inside. And what will happen in that regards when we open the brackets and everything? So our main aim is to cancel h from denominator so that we can substitute h with 0. So that h is cancelled, and to be able to cancel that h, so we must have only the terms with including h in numerator. Okay, so here we can say the terms without h should cancel. The terms without, which does not have h, without h should cancel each other. Okay, should cancel each other. So we don't want any term without h left there. So that's what happens actually. That's what happens. As you see, what we got here is the terms with h. So the terms without h cancelled. That's fine. And then that's why, and that's how we take h as a common factor, and those cancel. And as a last step, we can substitute h with 0. So when you substitute that h with 0, you get the final answer. And as you see in these questions, final answer only is 0 marks, because anyone can get the derivative applying the derivative rules. It's not the practice that you know or how to apply derivative rules. You can do that, like you can say, oh, okay, according to negative 2x squared, the derivative must be negative 4x. And yeah, and the answer that we got is right then. So you can do that to check your answer. But you shouldn't just write the derivative. That's 0 marks, as you see. And there is you may lose marks for notation, incorrect notation, and there are marks where you get finding f of x plus h, and the factorizing is a mark in such questions, the substitution. All right, it could be usually 5 marks, but as you see sometimes, as in this question, the question can be given 4 marks only. Okay, then after first principle questions, there are questions with applying derivative rules. Here we will never apply the limit thing. In such questions, actually, we will just apply that rule. There is only one rule. We can say anything axn, the derivative of axn is you multiply the coefficient with the power of x and decrease it by 1. Okay. However, to be able to apply this rule, we must done some fixing. Okay. So there is this rule, yes, and according to the level of the questions they ask you, that's the only rule, yes, but then there are fixing part must be done. And what does that fixing include? So it includes, we don't want x in denominator as a fraction or inside the root. Okay, so x can not be, there are 3 conditions in denominator. Okay, that must be fixed inside a root, inside the square root or cube root, whatever, or x cannot be written as a product. Written as a product. So we can't, we must open the brackets in that case. So these 3 conditions must be fixed. Okay, so those things, if whenever you have actually such questions, they give you those conditions, those things to be fixed. So once they fixed, then the rule above can be applied freely. Okay, so that's why we can say in such questions there is fixing part, and after that we can apply the rule, the derivative rule, into our terms. Now 6x, all is fine. Derivative of 6x is just x. Like if you think with the rule, what happens there is, what's the power of x? It is 1. So 6 times 1 is 6, and decrease 1 by 0. You don't really need to write it, but that's what's happening. So 6 times 1 and x to the power of 1 minus 1. So that's basically 6 times 1 times 1, because x to the power of 0 is 1 as well. So it's basically 6. So derivative of 6x is 6. But now here we have two problems. What is that? X is inside rule and x is as a product. You see x squared times root x. So there are two things to be fixed here. So how do you get rid of if something is inside root? I can just write here, if there is root x, you can write it's x to the power of 1 over 2. If there is cube root x, you can write it's x to the power of 1 over 3. Or if you have cube root, for example, x squared, then you can write it's x to the power of 2 over 3. So we want to write x as an exponent, okay, not inside the root. So that's how we can fix the part for the root x. Now it has to be multiplied with x squared. So we must get a single term so that we can apply the rule. So okay, so as we see in the formula, that's actually done only in one step. It's just x, okay. So you have 4x and x to the power of 1 over 2, and then what happens there, you can join x and x 1 over 2, and then we can apply the rule. Okay, so just as you see, you don't need to write x 6 times 1 times x to the power of 0. You just write the answer. Derivative of 6x is 6, and derivative of that thing is just that. Okay, that's it to get the marks. And then the last one, okay, let's go through from the memo. So that d notation is actually, so derivative of a term, so y prime can be written as dy over dx, or it can be written as dx and then y. So they all the same thing, derivative of y in terms of x. Okay, only that first one, when it is just y prime, it could be derivative of y in terms of t or k or anything else. But if it is not explained in any other ways, and if y is already in terms of x, so you just accept this is the derivative of taking y in terms of x. Okay. Now, what we said in such a question, x should not be, or the term that we are taking derivative, in this case it is t, it should not be in denominator. So see, do we have a product? No, it's okay. Do we have a root? No, it's okay. But we have a problem. T is in denominator. Now, in that case, the method is we must split into two fractions. You remember, split into fractions. So depending on how many terms in numerator, so we can write as 1 over 6t squared and minus 3t squared over 6t squared. So we got two terms. So those can be fixed. So 3t squared over 6t squared, so t squares cancel 3, it's 1 over 2. Okay, but then when it is 1 over 6t squared, 1 over 6 stays in denominator, but t is still in denominator and I don't want it. So I can take it up as above t to the power of minus 2. See, that is fine to be able to take the derivative. So then I can just apply the rule, 1 over 6 times negative 2, and decrease the power by 1. Just be careful applying the rule correctly. Okay, when you decrease the power by 1, so how do we get actually that thing? 1 over 6 times negative 2, okay, 1 over 6 times the power, which is negative 2, and x, decrease the power by 1, negative 2, negative 1. Okay, that's how you get that last answer after all. So this is what is done. And the derivative of 1 over 2 is 0, so you can just not write anything at all. Okay. Now, as you see, the first questions have the first principle, applying the first principles and derivative rules. And let's carry on. We will get questions with the cubic functions and with the application of calculus. Let's see this cubic function question. The graph is already given. But some coefficients are missing, and we have a, b are turning point. As you see, cubic function. You know there are two types of cubic function as we explained. Just like you have a happy face parabola or sad face parabola, we can have increase, decrease, increase cubic function, or other way around, decrease, increase, decrease cubic function. So that's when a negative. Okay, and in straight lines, how does it work? It can be always increasing straight line or always decreasing straight line. So those are the possible different graphs of a straight line or a cubic function, okay, when you had that condition. Now here a is positive, it's just x cubed anyway, so it is the type that, so which one does it look like? The one we have here is actually, as you see, it's this one. So it's increase, then turning point, then decrease and increase. Okay, all is fine. Now show that the values of b is -6 and c is 9. So what we said in such questions, never ever make an assumption. Don't substitute b is -6 and say, oh, it works. Don't say that. Actually, you have to find them. Okay. So the only point that they give you the answers in 6.1 is, you know, you can use them in 8.1. You can use those answers given in 8.1 in 8.2 or 8.2. You can use them in the following questions, not in this question. So basically in this question you have to find the values of b and c. That's it. Find it. Just like you don't know them at the beginning, and find them. Okay, and at the end of the day, when you get the answers, you'll say, oh yeah, I got the same answer. I got the same answer that they asked me to find out. That's what you should say. Okay, just imagine you don't know them. You are looking for b and c values. Do not ever make any assumption or use them in the question they ask you to find those values. Okay, but we said you use them. 8.2, yes, we can, if we need, we can use it. No problem. 8.3, all is fine. Okay. Okay, actually, let me do that. Like what? Let me solve 8.2 first. So to solve 8.2, for example, it's coordinates of b, and you know b is a turning point, so I know it's going to be first derivative 0. It's the x-intercept. So now, I need to have the derivative of the function. So to be able to solve that function and take the derivative, basically, I must know the function, and I can. That's what we said. F of x is x cubed plus bx squared, so it is -6x squared, and then plus cx, so it is plus 9x, and then -4. So what's the first derivative? The derivative is 3x squared minus 12x plus 9, and make it equal to 0 because it's a turning point. So how do we solve it? Divide everything by 3. X squared minus 4x plus 3 is 0. So we got the answers x -3 and x -1. So coordinates of a was 1 and 0. Okay, so let's just not say 0 straight. So x is equal to 1, that's for a, and x is equal to 3, that's for b. Now, but how do we get the y coordinate? I have to substitute 3 into the original function. Okay, in the case of x is equal to 1, I already know the y value is 0. Like, that's my point A. I don't need to worry about that one. But the point they ask me is actually 3 and something, and that will be my answer for b. So to be able to get that answer, I can just say, okay, it's b 3 and something. So you substitute 3 into the function and find. You see, we use the value of -6 and 9. Even if you couldn't solve 8.1, we can solve 8.2 using the values they gave in 8.1. But you can't do this in 8.1, okay? You can't substitute the values of a and b, in a and c into the function and somehow say they are working. No, don't say that. And 8.3, the function increases. So when is it increasing? It's actually the type that we said, it increase, decrease, increase. You see, that's before a, it's increasing all the way up. Let's just do that way. So it's increasing all the way before a and decreases. Then after b, it's increasing again. So how do you write before a and after b? It's just, we know those values. When x is less than 1 and when x is more than 3, this graph is increasing. That's it. So that will be enough as a full mark answer. show that the point for what values? Show that the point of inflection lies in the straight line G that passes through CD. So inflection point is which point, and how can we show it lies on that straight line at G? So do we know the equation of G? No. But what we know it's x-intercept, and we know it's y-intercept actually. -4 is y-intercept, x-intercept is 4. We know that so we can get the line equation. But according to this question, which is mentioning an inflection point, we have to find that point and then show that it actually lies on that line, on that straight line G. So what's inflection point, by the way? It's the second derivative 0. So I already got the first derivative in 8.2. So let me just write the second derivative now. So it is 3x squared becomes 6x. So derivative of the first derivative, remember, minus 12x becomes minus 12. That's second derivative. And when it is 0, it gives me the inflection point. So 6x is 2, and 12x is 2. So the x coordinate of inflection point is 2. But again, to get y coordinate, we must substitute 2 into original function. So y coordinate will be f2. Okay, so that will give me the y coordinate. And to be able to show that is on the line passing through CD, we can just show they have the same gradient, like gradient CK. We can say this point is K is same as CD or KD, or you can find equation of CD and then show that that's on the line. Okay, there are a few ways to show that the point 2 and F2, whatever it is on the line. Okay. All right. Now 8.1. We'll go through these solutions again through memorandum. Let me give you the idea now. 8.1. So let's come back 8.1. So we use that numbers to solve the following. But now how do you show what information we know? You see, we know a turning point, which is x-intercept as well, and we know the other x-intercept, and we know the y-intercept. So using those points, we can actually find the equation of the line. Remember, equation of the cube. Cubic functions has in this form, if you write the root form, there is x minus x1, a times x minus x2, and x minus x3. So that's the form of root form of a cubic function. Now, in this particular case, we don't know what a is. We will find it. But now, the good thing is, there's an x-intercept which is 1, but then because the turning point, remember, I will write it twice. And the 4 is my last one. So that will be my function. And to be able to find a, I will substitute another point. So the other point is 0 and minus 4. So that's my function. So when I substitute 0 and minus 4, so I'll say minus 4 is equal to a times. When you put 0, it is minus 1 times. When you put 0, it's minus 1 times minus 4. So from here, we got the value of a. Value of a is 1. Okay. Actually, we already knew it was 1 anyway. So we could just skip that step and put 1 since it is given. So it could be placed as 1 even at the beginning. So I'm just solving like if whether there is a coefficient of x cubed and they want you to find out. That's how you find out. Anyway, we still didn't get B and C. How does it work? So from A, then we can just say this function is basically x minus 1 square and x minus 4. That's actually the function. Just open the brackets and write in expanded form. So if you do that, it's what? X squared minus 2x plus 1 times x minus 4. Yes, open the brackets. So it is x cubed minus 2x squared plus x and times by 4 minus 4x squared. What else we have? Plus 8x minus 4. So if you just simplify, there is x cubed minus 6x squared plus 9x minus 4. So you got it. After you find the whole equation, now you can tell me b is equal to negative 6 and c is equal to 9. So you find the equation and then you tell me the values of b and c. But as I said in this question, we don't really need to make that substitution at the beginning since a is already given as 1. Okay, now if we check the memorandum, yeah, as you see in the solution they just put 1 here because it was given. It's basically just opening the brackets, and then when you make the substitution and expand, make your expansion and open the brackets, you got those answers. Alright, and then the first derivative, so 3 gives you -4, which we didn't substitute, that's good. Less than 1 or more than 3, that's fine as well. Point of inflection, when you substitute 2 and you find the equation and you substitute on the equation. Alright, so that point is -4, we can just write there. When you write that's -4, the coordinates of P, and you can say x is less than 1, that's correct, or let's not say and, say or, that seems to be better. X is less than 1 or more than 3 if the function increasing asked as a condition, so those are the conditions. And here we got minus, what is the coordinate? It gives -2, yes. So now the coordinate is -2, so we have a point to be shown that it is on the line. Which point we are talking about? What's the inflection point? 2 and -2. So the question becomes, how come can you show this? It's a point on the line CD. You can find the equation of CD. Don't give a lot of time. It's just you see, as you see, 4 and -4. They just said gradient is 1. So this line equation is x -4 and y-intercept is -4. And basically to show that point lies there, when you substitute x with 2, what is y? 2 -4, so y is -2. So you got the y coordinate. That's how you show it. Okay, so we have the straight line, yes, and when you substitute the point that you are looking for, whether it is on that line or not, what do? You substitute the x coordinate, and if it gives you that same y coordinate as the answer, y is equal to -2, then yes, that point lies, just write the conclusion, on the line we are looking for. Okay, now, and then this last type of questions in calculus section is application of calculus. So it can be a diagram given, a real life condition, or whatever the situation is. Let's see what is it about. Now a rectangle length x and y described, so that's x, that's y, so it's in an isosceles triangle, that's important. We know the height, okay, that's isosceles triangle is important information. And then yeah, so those triangles are exactly same and similar, that's fine. So express y in terms of x. Now what do we know about the relation of x and y? So that's height, that's x, and that will be 10. So the ratios will be same. You see, we are given this 10 and 8. Okay, so we are given 10 and 8. So 8 will be the height and 10 will be the base. We can say that way. So when we are observing the triangles, so they give it as a hand. Triangle APQ and ABC are similar. So since they are similar, their heights and everything will be the same ratio. So what will have the same ratio? Like if you just expand a line from there, like let's put a line down here. For example, we can do that as the height, you see. So the height is 8 and the base is 10. So we have two triangles which has the bases x and the other bases. Let's just draw the height from a to x. That should be enough because other one is already outside. Okay, so now what are we talking about? This height from 8, we can say that is 8 minus y. Okay, so this is 8 minus y, and then the base is 10. So that's what we are comparing. We have a triangle with base 10 and the height is x minus y, and we have other triangle, the base is 10 and the height is 8, and those are similar triangles. So since they are similar triangles, they will have the same ratio, and that is how we got a relation between in terms of x and y. Okay, this was a really quite challenging question then, because it includes some Euclidean geometry as well, using the similarity. From then it could be easier, because show that the area of rectangle can be expressed as, so area of rectangle is just x times y, so you just multiply x times y, and then that's 1 mark. But then when you substitute the y value in terms of x, when you write it, you will find the area only written in terms of x. Okay, and remember, let's say you were not good in finding such things in 9.1 and 9.2, you can still solve 9.3 because the formula is given, and whenever they ask minimum or maximum, doesn't really matter, it's basically the derivative of that formula is equal to 0. So you can take derivative of a, yeah, that's an easy derivative. Derivative of 8x is 8, so it's just taking derivative of a and equating it to 0. And as you see, it is 2 marks, like taking derivative is 1 mark and equating to 0 is 1 mark. That's very important. And then you just solve for x then. So you got a x value is 5, and that means it must be half of a for the maximum area. So according to x is 5, you can substitute into the original function, so it gives your maximum area. Determine the dimension. Oh, it's not asking the area, it's just asking the dimensions. So you can substitute into y equation. We said we had written y in terms of x, so then from then you get the y length of y. Right, this was an application of a calculus question. As you see, question 9.